All right, just wanted to show you what it looks like on the unit real quick before I take it off. So that's the whole old tank assembly there. And this is the timer unit up top, which is what we'll be looking at. All right, sorry I can't find my usual black background here. So this is a gonna be hard to keep it all in frame, but this is a the timer off the top of a, I believe it's a Model 89 is what they're referred to, water softener. It says model number 445437. Something rubbed off. And something else. Ugh, leaking goop. So, let me back up for a second. For all you city folk who don't have water softeners, let me find something to draw on. Okay, so this is just like, 100-foot view of what little I know about water softeners. So, sawdust. So, you got the well, right, which is underground. And you got raw water coming off the well. Typically, what will happen is you might break off, there might be a T in here, and you might use some of that untreated water for maybe like your hose bib or, irrigation system. That's the one. Like a lawn irrigation system. Places where you don't really care about having the water being treated. So the issue is that this water straight out of the well is going to be chock full of minerals. Where we are, we got tons of rust in the water, which just screws with all the fittings. I've got, tons of plumbing fittings we'll be looking at eventually that are all corroded out because of this old water softener that they had in here. So from there, it's going to go to a softener. And then it's going to supply the rest of your house after that, right? So this softener, the way the softener works, get a fresh sheet of cardboard here. So the softener has two components. In the modern ones, they combine both the components into one. But it's got a tank, a mineral tank, which will make like a little tank like that. And inside of here, so this is the mineral tank. Inside of here are little beads that the water comes in and then goes out again. And I'm sorry, out of the softener, this would be like all your plumbing fixtures. So like, sinks, toilets, etc. Shower. Right? Okay. So you got raw well water, and then this goes out to your fixtures, right over here. And inside this mineral tank, these little minerals absorb the minerals that are coming in from the raw well water. So there might be some, because I popped the tank. Let me see if I can get a little handful of the minerals. Okay, so these are the little, they look kind of like fish eggs. There's some driveway gravel mixed in there, but they look kind of like fish eggs. They're real tiny. But these are the little mineral beads, and what they do is absorb all the rust and other minerals that are in the water, right? And then you get what we call softened water out. So those are the little beads, right, which are inside the mineral tank. Now, the problem with this is eventually these beads become saturated and they won't absorb any more minerals out of the raw well water. So what we do to fix that is we've got usually, in these old units, a separate tank, which is a brine tank, which is where you put the salt in, the softener salt. And what happens here is periodically there's a flush cycle where the brine goes through and washes all these minerals, and again, this is 1,000-foot view, just to give, a basic overview. I don't really know the chemistry in detail here, but essentially, you're just going to wash these little beads, and somehow or another, it replaces the bead or the minerals from the raw well water, and washes them out of the brine, or washes them out with brine. So, this brine goes through here. It washes these little beads so that they can continue to function. And then it usually dumps whatever brine it uses overboard, into your septic tank or your sump well or whatever, right? So, okay, that's the 1,000-foot view of what's going on here with all that. Okay, so the issue is that that recharge cycle that I talked about, you don't want that to happen just any time. You don't want to be using the water while that happens. So that's where a timer comes in. Now, nowadays, like the new one we got is all digitally controlled. So it's got a digital timer, but this is probably from like the 80s would be my guess. And there is, I don't know, it'll be easier to see once I get this a little ways apart. But there's a analog timer mechanism in there. So what I'm going to do is I'm just going to kind of walk you through a little bit of what's going on here. So we'll kind of start with this stuff. All this should be fairly simple. So we've got two valves here, an in and an out. So the water is going to come in the in, right? So this would be your raw well water. It goes into what's called a bypass valve. Pretty much all of them that I've seen have this. And it's a slider valve that shuttles back and forth to be able to bypass the well water. So that's really all that's going on there. Pretty straightforward. And then this is the outline, which would go to your house to supply all the fixtures and whatnot. So I'm just going to start taking some screws off here and see what we find. And just real quick, all these fasteners appear to be not your hardware store grade of stainless, but they kind of look like the 316 stainless to me. The slightly nicer, like marine grade stainless. They don't have that. See how they have kind of like a darker luster to them? That's, I guess there's extra like molybdenum in the, extra molybdenum and extra chromium, I think. Well, there is no molybdenum in like 18.8, but this has molybdenum, I think higher chromium and higher nickel content, which gives it kind of a slightly darker luster. And they're better. They are more resistant to corrosion than a regular 18.8 fastener, which makes sense because these are going to be around basically brine. So they need to be, almost like you would have in a seawater environment, grade of stainless. Okay, so here's the bypass valve. See, it's all gunked up. So it just sits in there with a couple O-rings, and these O-rings are starting to come apart. If you touch them, you can feel how they're all like, oh, that might just be some grease, actually. Yeah, that's just some grease. So those O-rings aren't too terrible. But that's just the bypass valve. So all we've got is just a shuttle that runs back and forth and, allows you to just go straight raw water into the pipes if for some reason you're having issues with your water softener, or in normal mode you would be running it through the softener. So maybe you got to do an extra recharge cycle or something on the water softener. You could bypass it for a few minutes and at least be able to flush your toilet and all that kind of stuff. So that's really all there is to that. Okay, and this would be the drain line. So at when it's done with that recharge cycle, it's going to run all that brine that's full of all the rust and stuff out, and then this would go probably. A lot of people run it into their. I think a lot of people run it into their sump pump, like the basement sump pump, which doesn't seem like a great idea to me because you're just running briny water over your sump pump, and your sump pump's not going to last nearly as long. So optimally would be into the plumbing and, you know, out of the house into, you know, the septic tank or whatever. And then this line here, which is all electrical taped on, is the line that would go to the brine tank. So this is going to be the pickup. Jeez. It's like they didn't want it to come off. Ugh. Obviously, it was leaking at some point, and rather than fix it properly, just slap some silicone tape on there and call it good. So this is the line that runs to the brine tank. Just a compression fitting with you know, some plastic tubing. So this will actually pick up the water out of the brine tank. I think that's right. Yeah, and I think it also puts water into the brine tank. So it will fill up the brine tank with water. You know, the water sits in there with the salt, becomes all briny, and then it would get sucked back out to do that recharge cycle. So I'm going to get rid of all this just to get it out of the way. Now, I guess we're about to the point where we got to start pulling this apart. I'll just set that down there. All right. Jeez, all kinds of stuff falling out here. Let me see if I can break this down a little further just so we can look at it a little bit easier. Again, this is a little bigger than the stuff I normally take apart, so, you know, framing is, ooh, a spider. Framing is a bit of an issue. Wow, this is quite the little Rube Goldberg machine here. Okay, well, got a little further along here. So just a metal bracket that holds everything. It appears to be some sort of stainless. Could just be chromed. Easy way to tell if it's stainless. It's not a foolproof way, but it is a way. So we've got a magnet here. That's pretty magnetic. I think that's just chromed or nickel-plated steel, I think. Nah, it looks galvanized. Yeah, so just galvanized steel bracket, I think. Nice and thick, though. Nice and beefy. That's going in the scrap bin. Okay. So we'll break this down into pieces that we can figure out. It appears that something was broken here. This guy, whatever it is, didn't appear to be hooked up to anything. Looked like it was supposed to be hooked up to something back here, but who knows? It could be, I don't know. All right, let's look at this first. So this is the timer assembly. So what I see going on here is we've got a transformer. This is almost certainly to give us 25 volts to run everything. There's a sticker here that says 115 watts, 60 hertz, idle watts, 23, impedance protected. Oh, I'm sorry. That's a motor. I'll prove it to you. Give me a second. All right, so I believe this would be a shunt wound AC motor. So we've got the little armature here. And I guess here's the shunt windings here to get the thing to turn. So a single phase AC. You've got two shunt windings, again, to give you two phases for the thing to be able to turn. It is riding on what appears to be a bushing up top here with a little spacer in there. And then on the front end as well, it's also riding in a bushing. Wonder if All right, let's leave that alone for a second. So we got an AC motor here. The AC motor appears to be controlled by these micro switches. Well, we've got two micro switches. We've got one. Oh, interesting. They both control the AC motor. Okay. So they both control the AC motor. This is the part that's going to be nearly impossible to figure out here, I think. So this is the timer mechanism. And again, nowadays, this whole Rube Goldbergian thing here is going to be replaced by just a computer. So you do away with all this and you just have a computer-controlled device. All right, so we've got 110 volts comes in here. I cut that. Comes in here. We got the ground. So all this metal back here is negative ground. So if anything shorts out, it's going to be no problem. We've got hot wires coming into two micro switches here and here. And into this rotary dial, which is probably going to be a tick timer. We'll hopefully get it apart here and see exactly how it works. And then we've got 110 volts going to the AC motor. And then we're completing grounds through. So both of these are. So this is going to be, I bet, one of them is going to be an open. One of them is going to be completed when the switch is open, and one of them is going to be completed when the switch is closed. So it's like a flip-flop switch. Same thing on this guy, but they're only using one of the poles. And man, this is complicated. All right, so let's back up a second. So here's the directions on how to set this thing. Hopefully I've got everything in frame. Okay, so if you need to reset your clocks due to power failure, change daylight savings time, or other reason, then remember to reset your conditioner's climber. Should you have need of additional conditioned water because of extra heavy demand, your unit can be recharged at any time without interrupting the automatic program cycle. If you should desire your Culligan conditioner to recharge at a different time of day than that which is established at the time of installation, you can readily reprogram the timer. Okay, so to change the recharge time, position the small peg A. Good Lord. Okay, so that's this guy. Well, I guess that was in that orientation. Small peg A to the tab that corresponds with the conditioner time. The corresponds to the time your conditioner now recharges. So this sets the. Okay, so you're selecting what time. So let's say we want it to go at noon. You wouldn't want to. You want it to go at 2 in the morning or something. So we'll go 2 in the morning, right, when nobody's using water. To change the time of recharge. To change the time of recharge, grasp the outer dial B, this guy, and rotate it into the recharge time is opposite the small peg. The dark area indicates 9 hours whenever the recharge time is changed. The time of day setting must be adjusted as follows. To set the correct time of day, grasp C. Wow. I think a computer is considerably better here than that. Rotate till the correct time corresponds with the arrow. So we'll say it's noon right now. Okay, so this dial is setting a recharge time and the current time of day. So that thing is going to be all in this. So this must be, I mean, this is the timekeeping device of some sort. I bet you, we'll try and take it apart, but I bet you it just works off of like the 60 hertz to keep time. But we'll see here. To get additional charged water, to manually recharge, you're going to pull this handle down. And then you've also got, I think this is a salt, like how much salt you use, but it doesn't really say. Okay, so it looks like this is like a factory adjustment here. They don't intend you to do anything with it. So that amount of adjustment is what is the whole thing. Then if you wanted an additional recharge here, there's a little tab back here that pushes on this and forces it into the recharge cycle. So we've got a couple of tumblers back here that are designed to push the switches at different times. So, man, good luck figuring out what does what on this. This is going to be quite the figure-outy thing. All right, well, let's see if things become more clear. I'm also not seeing anything that explains what this does. Now it looks like that's triggering the recharge. I'm going to set this aside for a second. We're going to take a look inside of this unit and see if we can get any clues, because I am not immediately seeing what does what on here. I'm fairly certain this is the salt adjustment. This is just a timer assembly running through gears here and obviously causing stuff to rotate. And when it hits a certain point, it's going to trigger a recharge somehow or another through these switches back here. But I guess we're going to have to see what this motor is doing. Yeah, this is quite the little contraption. Okay, so again, those are those micro switches. We got one circuit on one, which is probably just going to be an on-off. And then we got two circuits coming out of here. So what that's going to be is in one position, let's say the brown wire would be activated. In the other position, the yellow wire would be activated, or, you know, possibly in reverse. I'm not entirely sure. But, okay. So, I suppose we can get rid of all this. Alright, so again, that's just the backing plate to the whole thing. It was grounded out. And just, again, looks like galvanized steel. Okay, so there are a couple of functions that are going to be going on in here. There's going to be a, well, the water is normally just going to be flowing in and out. The recharge cycle is all this thing's really going to be controlling. So we are going to have, that's just a plug. I don't immediately see any way to take this apart. I think it's going to be just a case of it was spot welded together. So we're probably just going to have to break it apart. Let me get a hammer. So these are just the inlets and the outlets off the top of the tank. I'm sure it's probably pretty apparent which is which. And I just cut them to get them off the tank, which is why they're all goofy. So, yeah, those just connect right there. This plug, I'm still not really sure what it does. So this appears to be a shuttle valve. So I think that this is hydraulically, most likely hydraulically operated using water pressure. So what must be happening here is, I bet this assembly is a rotary valve. Ah, man, you guys are going to want me to take it apart, aren't you? Dag nabbit. All right, I'm going to see if I can cut this thing somehow down the middle. somehow or another. I'll be right back. Okay, I still can't get this thing apart, but getting there. So I got this valve out here, which is what I think is probably a rotary valve. There's a little screen on it, I'm assuming to stop it from collecting gunk. And the mystery deepens, because that does not appear to be a rotary valve. It appears to be something else. Okay, this also looks to me like a shuttle valve. So we got a shuttle valve driving a shuttle valve. How does that make sense? Well, I am still not immediately seeing how this affects anything. It must be another shuttle valve where, this is an open port. So you got open ports, on either side. This thing scoots, blocks off the ports, scoots the other way, allows stuff to flow, probably happening on both sides here. And that gets driven back and forth. Okay. Man, this thing's like an automatic transmission. There's all kinds of crap going on in here. So, I broke this apart. So we had, I can't remember what I already said and what I didn't. So I'm just going to start over here. So we had this, which was in the back here, which appeared to drive this shuttle valve back and forth. We also had this big bore in the middle with this guy, which also appears to be a shuttle valve with no apparent way to actuate it, at least in terms of the motor assembly. So this armature, these splines were attached to something. It's escaping me at the moment. They were on something. Okay, so on the inside here, so we've got the main outlets here. So we've got the in and the out. So water's going to come in here. It is going to drive this shuttle valve. I don't know if I can get it back in there. If I do get it back in there, I don't know if I'll ever get it out again. Okay, so it's going to come in. It is going to not be able to get in here because of the shuttle valve in the way. And then it will flow down. All right, back up a second. So the water is going to have to go into, so it's coming up from the tank here. It's going to have to go into this port, which seems like an awful big restriction. And this port is also the backside of this shuttle valve. Now that shuttle valve must normally be kind of like in this position, maybe. And then somehow it gets behind this shuttle valve, which we have in there, which I don't immediately see, goes through here, and then it can come out of the out port of the water softener. So this top shuttle valve must control, so it was inside of this bore here, this top shuttle valve is going to sit behind. All right, I think I'm starting to get this now. It's going to be sitting behind these. So this was the water inlet from the brine tank. This is exhaust, I guess we'll say, right? So this shuttle valve must either move something like this to pull brine in to the tank. I think there's a tiny little hole underneath there. It's kind of hard to tell because I destroyed it. So it must sit something like this to allow brine to come into the tank for the recharge cycle. And then it must move over something like that to allow to block off the brine, or maybe it moves back, who knows, one way or the other, to allow this to pump out, using the fresh water out to, raw well water to evacuate the tank. So this shuttle valve in here, so we had a limit of travel on this thing. Limited by, this guy. Okay, so this was up against that back there, and if you recall, this had the little clevis pin in it. So I'm just trying to get an idea for how far this thing can actually move back and forth. Okay, so that's maximum travel there. All right, I think I see what's going on here. So I think this is a backflush valve. So all this is doing is reversing the flow. So under normal circumstances, this valve, and I think it's just getting shuttled back and forth by water pressure, although I don't immediately see how that happens. It's a mystery wrapped in an enigma, wrapped in a bigger mystery. So this guy normally sits here, and when it scoots over this way, I think what it does is it's reversing the flow of water to allow fresh water to come in and backflow out of the tank and get pushed out of the exhaust. Now, why it moves or what actuates it, it's got to be water pressure on the back side of this valve. So there must be, when this needle valve, or this little valve, moves back and forth, this guy must block or uncover this port, I guess. And it must use the pressure of the water to shuttle this thing back and forth. Sorry I can't be more insightful here, but I'm just kind of making it up as I go along. So that's the best I got for this thing. Maybe someone can link to a better description of how this works, but that's kind of my best guess at what's going on with that. Anyway, so this guy, let me get that snap ring out. Okay, so again, this was that rotary valve, or what would you want to call it? It's like a cam, so it's going to actuate and deactuate these switches. And you can pretty much give up on me telling you what does what, because I don't know, this thing's pretty complicated. All right, so that little shaft is retained by a couple of roll pins here. Let's see if I can get at least one of them out. Or break it, that works too. Okay, so we got a couple of planetary gears, which is just the gear reduction for the motor. I don't know which one was where. But that's all that is. It's just a gear reduction. Planetary gear, or not planetary. Just a bull and pinion gear reduction for the motor. So that's all that is. It's just basically a transmission to drive this cam. A couple extra gears there. Can't have too many. And one other thing to note here, that grease actually looks pretty good still. It's not completely separated out. Still is pretty greasy. So That's kind of surprising because that's probably at least 30-year-old grease at this point, maybe even more. Probably more like 40-year-old grease. All right, and then we got this guy. We'll just see if there's anything we can see. Okay, just broke the shaft there. Man, why are these dang things so hard to take apart? It's like they wanted it to last. Okay, so this top piece, which is the timer, this looks like just a planetary gear reduction here to run this little shaft. I don't think there's going to be anything too crazy interesting in there. Well, it could just be a stack of bowl and ring gears, or what would you say, pinion and ring? Pinion and bowl? Pinion and bowl? Let's go with that. Pinion and bowl gears through here to do some sort of a, well, torque multiplication, almost definitely. And you know what? I think that this is just an AC motor. So, yeah, I think it is. So this is just a little AC motor, and all they're doing to keep time is to, because this is going to run at 60 hertz, right? Yeah, so that's just going to spin at 60 times per second. And, yeah, so there's the windings in there. And the armature. And then that's just going through this gear reduction here to keep time. So that's going to be slowed down to, well, it's even further gear reduced. I think it was gear reduced to give you this thing rotating once a day. So, you know, 60 times per second all the way down to one rotation of this every 24 hours. And, yeah. So, I mean, this is what it takes if you don't have a little computer chip to run a water softener like you do now. This is the old mechanical way of doing it. I mean, you can see why everything would be so much more expensive. I mean, in a modern day unit, I'm sure that this little shuttle valve is just replaced by some solenoid controlled valves. And of course, this whole thing is just a little microchip. Just a little microchip that's going to control everything. So, sorry I couldn't be a little more insightful as to what's going on with this thing. But there you go. Hopefully that's interesting to someone. So, thanks for watching.